Hi, welcome back to this video series on program analysis, program synthesis, and SMT solvers. Today I'm going to talk about a simple problem. I need the solution to this problem for my next segments. So I'll first start with the problem statement. The goal is to derive a function which will check whether the two numbers x and y are of the same sign, meaning if both x and y are on the right hand side or on the left hand side of the number line. Okay, that's basically what we wanted to figure out. Of course, this is an easy problem to solve if we allow the if statement, right? All we have to do is if our x and y both are in this side, then we say yeah, it is same sign. If both of them are on this side, meaning less than 0, then we can conclude they are both same sign. Otherwise they are opposite sign. But what if we are not allowed to use the if statement? Okay, no if statement should be used, but we should be able to tell whether both numbers x and y are of the same sign or not. Okay, so we are given two numbers x and y, and we need to decide are they same sign or opposite sign. Okay, how do we do that? We can easily solve this problem using program synthesis, as I'm going to show to you now very quickly. So I'm going to show you my grammar specification, and then I will be synthesizing this program automatically using the program synthesizer. In this video, I'm going to use the specification approach rather than training it by example. So what specification is much easier to write in this case, right? The specification is this, right? You have x and y as inputs. If your x is greater than or equal to 0 and y is less than 0, and also another possibility is x is less than 0 and y is greater than or equal to 0, right? These are the two possibilities. That's why you see an or statement. If one of the possibilities is true, that means the numbers are opposite sign, therefore the program will return 0. Otherwise the program should return 1. This is basically the specification. Okay, this specification is used by the synthesizer to come up with another program, but that program will not use the if then else statement. This is an if then else statement, right? IDE stands for if then else. As you can see here, nowhere I have specified if then else. Okay, it's just we are only allowed to use bitwise operators, and we want the program to synthesize some program which will satisfy the spec. Okay, the program takes two inputs x and y. For scalability reasons, I put bit vector to be of size 4, which will allow me to generalize it to large bit vector size easily. Usually the program output is independent of the bit vector size, so we can abstract the size easily. It's much easier to do manual. Okay, that's basically what I'm trying to say. So let's run this thing quickly and see whether we can synthesize it. Yeah, we got a program synthesized straight away. The program name is called same sign, or a function name is called same sign, which takes two numbers x and y as input and produces an output bit vector of size 4. As I have shown earlier, the bit vector will only be either 0 or 1. And as we can see here, the program is extremely simple actually. It is basically first doing bitwise OR of x and y. Remember bitwise OR of x or y. If two bits are the same, the XOR will be 0. Otherwise, there will be the XOR will be 1. So, so in this case, if our most significant bit is, say, for example, turned on for x and turned off in y, the XOR will be 1, right? And then we are doing a bitwise NOT of it, which means the answer will be, let's consider this scenario, that my x is greater than 0 and y is less than 0. Okay, let's consider this scenario. So what will happen to my bitwise XOR for the numbers x and y? We don't care about all other bits, right? We are only interested in the most significant bit because that's the sign bit. Okay, so what we are going to do is basically we are going to compare this bit against this bit. Okay, and in this case the XOR will be 1, right? Because this one place will be 1. Here is actually 0, and here is 1. This I call it X, right? And this is Y. And the XOR of these two will, we don't care about the rest, so we can forget about it. The XOR will be 1 at this point, and then we are taking a NOT of it. That means the XOR will become, this whole thing will become 0. Again, we don't care about the rest of the bits. So this part is 0 for this particular scenario. And what are we doing next? We are doing a bitwise logical right shift. Okay, by how many positions? By 2 positions. Remember, 2 plus 1, 3 positions. Okay, if I this is 0 0 1 1, which is 3. So I'm basically getting rid of the 3 rightmost bits. That means I'm only left with the sign bit. Okay, so if the sign bit is 1, then we say it's the numbers X and Y are same sign. Otherwise, we say opposite, right? So after we do this, what did we get? We have 0 here, and we got rid of the remaining 3 bits. So overall, this expression will be 0 for us, okay, which is perfectly fine, because remember, here our numbers are opposite, therefore 0 is the correct return code. And now you can enumerate yourself the other possibilities. The whole idea is to just compare the most significant bit of numbers X and Y, and then throw away the rest of the bits, and then decide whether the most significant bits match or not. That's basically what the synthesis program is doing for us. It's pretty clever that it was able to synthesize this just based on the specification we gave. Okay, that's basically it. And I will be using this construction, same sign, in my future videos. So let me quickly summarize what we synthesize. We synthesize a function called same sign, which takes 2 numbers X and Y, and it returns 1 if both of them are either positive or both of them are negative. Otherwise, it returns 0. So the logic is as simple as this. It takes X, it computes the XOR with Y. This little symbol, this is XOR. Okay, just to be clear, it's not exponent. Okay, so and then once you compute the XOR of these two, it does bitwise NOT, which is the tilde symbol, and then it right shifts by 3 position in this case, but we can generalize it to bit vector length -1, right? That would be more general formula, which should be true for all other bit vector size. Okay, in this case, the bit vector size is 4, therefore 4 minus 1 is 3. So this is basically it. Okay, and the beauty is that there is no if then else statement in this expression. We can programmatically synthesize this using the program synthesis technique. Okay, and thank you. That's basically it.